I'm Kyle Banerjee, and today I'm going to provide a brief introduction to digital preservation. The way topics like this are typically introduced is there's some background on why the topic exists, there's a description of what it is, and then we say how to do it. But in the case of preservation, I think a better way to approach it is to ask why we do it at all. After all, there's an infinite amount of information in the world. It's created at a furious rate. And so there's a serious question of why would we permanently commit huge amounts of time and money to preserve anything in particular? That's why I put the picture of the dog on the screen. Why this ball? I mean, I'm sure he picks up things all the time. Why not bury stick, rocks, garbage, raccoon poop, all those things? And the answer is it's all about use. That ball's his favorite thing and he loves to play with it. And we need to be asking ourselves, why do we really need to preserve this? If we cannot think of why someone would use it, we won't know how to preserve it in a way that will be useful for them. Use drives everything. That is why preservation is so much more than backing up files. If you just simply back things up, for example, if that dog just buries everything he likes, he's not going to have anything. And likewise, if we just back up files, we also won't have anything. Over time, the files will gradually become obsolete. And since we typically have trouble finding stuff on our own hard drives and network drives, even amongst files we actively use, when we start talking about things that we rarely or possibly never use, we won't be able to find those either. Another important point is that when it comes to preservation activities, the value of what we keep is very much connected with the metadata associated with it. If you can't find something, it may as well not exist. If you cannot manage it effectively so that it can be used, or if you can't use it for some reason, it also may as well not exist. Metadata, and when I'm talking about metadata, we're not just talking title and author, we're talking about all the information, technical, administrative, structural, you name it. Everything you need to make something useful. It doesn't mean it all has to be done manually, but the value of preservation activities is all about metadata and not just about storage. Another thing that is really important to keep in mind at all times is it is the practical effect of what that we're achieving rather than compliance with any standard or procedure which defines success. All of these standards and procedures exist for reasons, and we should always work towards those purposes. If we find that for some reason the procedure standard is getting in the way of its own objectives, then we should be questioning them. You should always question everything. There's a whole lot of stuff that you'll be happy that you don't need to know. I've put an alphabet soup of acronyms on the screen, all of them in some way connected with preservation. It's a partial list, and I honestly recommend that you don't follow up on any of them, not without a specific purpose, because otherwise that's kind of like reading a book on Java or Ruby on Rails when you don't even know what you want the program to do. Subjecting yourself to standards without context will overwhelm you with information that doesn't help you, at the same time not even expose you to what you need. Don't worry about the definitions of these things. I've only put them on the screen so that as a reminder of what they are. But it is important to know what all of these acronyms collectively aim to do. And what they aim to do is to provide a broad framework, a way of conceptualizing the entire preservation process, and to provide all the tools and procedures that you need to create, process, manage, and use resources. One really important point is that it is a mistake to think of compliance with a standard, like that systems comply with the standard, you shouldn't assume that they are compatible, because standards are encapsulated inside of other standards in many cases. We'll get to this in a second. And when you get down to it, it's all about meaning. And so there are multiple legitimate ways to interpret the same standards. And so when the same standard is interpreted in different ways, it can be very incompatible. To illustrate this point, the why standards are hard to implement. This is a subject heading, a Library of Congress subject heading. And since the Baghdad Theater is a corporate body, we can see that Baghdad Theater is not a unique name, because there could be other Baghdad theaters, like perhaps in Baghdad. And so that it's qualified with a geographic qualifier, city and state or city and country, that's prescribed by AACR2. And that the spelling for the geographical entity is determined by the Geographic Name Information Service, the fact that it's that it's subdivided by history. The subject cataloging manual does that, and this is just for a single subject heading. The format of author names, that's not defined by the Dublin Core or EAD or any of the other or mods or anything like that. There are many ways of interpreting this legitimately, and so if the content itself is incompatible, you're going to have trouble. And so when you take this single subject heading and then you put it inside another scheme such as Dublin Core, mods, mark, or a specialized domain schema, encase that in METs along with a bunch of other specialized metadata, you can see how complex the problem is getting. In theory, all the standards work together. Like this OAIS, that's actually the Open Archival Information System reference model. And what it is it's a conceptual framework for preserving information, and it describes interactions between information producers, consumers, managers, and the archive itself. It doesn't have any implementation details in it at all. And it goes on for 135 pages while giving you like no real details on how to do it. But it does provide kind of like an overview. Here's how you think about your preservation activities. And then you have the metadata encoding and transmission standards on top, which has expressed itself in XML, and it contains the structure along with administrative and descriptive metadata, which itself can be expressed in like mods or mark or Dublin Core, and then you have the premise dictionary. The idea is you have this stack of standards that works together. And by the way, don't memorize the order here, because you can have very legitimate projects that don't use any of these standards. The idea is there's almost infinite combinations for how you can encapsulate things, but that they work together. This is obviously very complex. And in fact, it's so complex that even experts have difficulty understanding them. The other thing is that many of them, when they devise these things, they typically devise them without regard to real world limitations. When you're working on a project, you will have to use mere mortals to do all the work with the resources that you have, and that in the future, the people that inherit this project will also need to do all their work with mere mortals with the resources they have. And this very complex web of standards were devised at a time when needs, systems, and procedures may have been different. And then I wouldn't even assume that they even had, your actual needs in mind. The main thing to keep in mind is, what do you really need to happen? Can you move things forward? Can you get the stuff out of your system? Can you put it in a form that a new system will be able to ingest? And if the answer is that you can move it forward, you're going to be okay. And if you can move it forward in a way that will still be usable, that is, you'll be okay. And if you can't, then that's not so good. When we run into a problem, we have a tendency to turn straight to the literature. But it's a mistake to think that just because something is written down, that the people who wrote it, who wrote their ideas down, know more than you do. And they certainly don't know more about your context. I'll give you a little confession here. There's a book I co-authored some years back, and I got some publisher feedback. And they said, we need a section on X, and we need it in a week. The problem is, I was completely unfamiliar with the topic. Now, of course, I'm going to write that section. I sent it back, and everybody was happy. And so I get quoted as being an expert in something that I'd only had a week's worth of exposure to. There are all kinds of reasons why people write things. Sometimes they know exactly what they're doing. Sometimes they don't. Even if they know exactly what they're doing, it might not apply to you. The main thing is to always keep focused on what your actual needs are at hand. Preservation is a very, very tricky thing because most of the procedures are actually kind of like built around the physical world. We treat digital objects as if they're physical, as if they're actual things when they're not. Files and directories and things like that, they don't actually exist. Not like they do in paper. The digital objects being created nowadays are becoming more and more connected to their platforms and less sort of like digital copies of analog things. For example, I mean, how would you preserve something like, I don't know, an interactive mapping tool? The library stuff is going down this route too. Linked data, the whole point is that the information is all over the place. As the system and the information in them become more tied together and more distributed at the same time, so you have lots of systems working together to create a single resource, it really brings into question, what exactly are we preserving and also how to preserve it. On the same subject, with the content being tied more closely to the systems they're in, many things that are described as best practices are in some cases not only unhelpful but outright harmful, and usually that's because of the needs have changed, that the needs have changed, and that our definition of preservation might be shifting. For example, if you have information in a content management system, you don't want to just take what effectively amount to screenshots of the content management system. It's about the information, and you might not necessarily be able to think of them as documents. Textual stuff is a lot easier than some of the others, but it's not just about trying to freeze things in time. Unfortunately, preservation doesn't give you very many options on how you do it. There is migration and emulation. For people in the audience who are over the age of 50, they will know what WordStar is. And if you're under 50, you probably have never heard of it. That was the king of word processing formats in the 80s. And that's why there's that age gap. And after that, it was WordPerfect 5.1, and then it's going to move on to Word and PDF and all that kind of stuff. The idea of migration is that you migrate files to more modern formats so that they all can be used. The trick with migrating things is you tend to lose information when you migrate. There's always a little bit of loss, and it only works with things that act like files. Now, emulation, the idea behind that is instead of changing the format, what you're doing is you're providing the entire environment. So for the example with WordStar, instead of migrating the WordStar document to a new word processing format, you're actually providing a computing environment that runs WordStar. But such solutions require you to know how to use WordStar. And so you have a ton of programs that nobody has any knowledge of that you have to use. That creates its own problems. And this way is also expensive and more system resources. Whether you use migration or emulation, both options are going to presume that everything's self-contained, which doesn't work in distributed environments, because emulation you can do an entire server, but if it's calling services that are on if it's calling services that are on other machines, you've got a problem. It's also not so great with things that are really dynamic or in cloud environments, as there are more things like that nowadays. One of the things I've always been fond of saying is that the main difference between the Smithsonian Institution and a landfill is selection, organization, and presentation. The Smithsonian carefully selects things that they think will tell a story, whereas in the landfill you accept pretty much anything. The Smithsonian, they organize these carefully curated objects into contexts. They provide metadata, to help tell that story, and then that allows them to present to the world. Whereas in the landfill, you really don't sweat the organization part. You just bring it all in, and that makes the stuff useless. My point here is that if you simply collect stuff without regard for selection, organization, which are critical to use, you'll wind up with a digital landfill, which is not particularly useful. And the selection needs to be driven by why are you doing it? How do you know that what you have, that what you want to preserve is even a good idea? And I'll give you an example of something that's a good idea to preserve. Like for a university, theses and dissertations. By definition, dissertations are groundbreaking work. They represent years of labor, and they highlight the output of the university. It's the pinnacle of, it represents, it's a culmination of someone's work at the institution. Theses are kind of like a lighter version of that, but no one else is going to do it. So this is a fairly well-defined body of work. The value of it makes sense. People use, especially dissertations, as resources. I mean, I personally use them myself, one-stop shopping for bibliographies. It's great for that. Makes total sense. What doesn't make sense, and which is all too common in library repositories, will be things like submitted student papers. There was never a demand for stuff like that. Before we had everything online, no one ever said, what would be great is if the library could find a way to keep all these student papers. There just was no demand. The only people who kept student papers before everything went electronic, well, fraternities certainly did. That way, when somebody else took the same class, they could just pull one out of the file and everyone could go drinking instead of working. And that was that. Also paper mills. There used to be, you could buy papers. These, with very rare exceptions, there's no particular reason to think these would have enduring value. And there's no reason for anyone to expect them. It's sort of random. And likewise, you don't want to be keeping stuff just because you can. It costs tons of money and time. There needs to be a reason. So selection, and then is very important. And then if you're acquiring things that are not really not very high value, you will not be able to, it's going to pull away resources from organizing what you do have. Best place to hide a tree is in a forest. So if you have really good stuff, one way to make it much less visible and much less usable is to hide it amongst stuff that's low value. Preservation requires active management. you're going to be constantly migrating over time, including metadata. And this is kind of tricky. If you've been through an ILS migration, you'll notice that you usually have all kinds of things that don't work. That's because the new system works differently than the old one. And the reason, there would be no point in migrating if it didn't. You're going to run into the same issue with anything else. And so you have to figure out, how are you going to go through, get the, like the administrative, the structural, the descriptive, all this kind of stuff to work together. And we already saw how complex the standards play in together, the various types of content containers. It's really tricky. How do you communicate, how things can be used, that stuff is real, and so on. When you study preservation, one thing that you're certain to hear about, actually two things you're certain to hear about, are both locks and checksums. I think you can safely ignore both, although you do need to know why they exist. Locks, lots of copies keep stuff safe, is based on a fairly simple idea. The idea is you just have lots of copies of something, and they are the copies are cryptographically signed, and if one copy gets corrupted, corrupted or deleted or whatnot, it is fixed in place. But the problem is this is done in an extremely expensive and inefficient way. I mean, not sure I can even think of a less efficient way to do it. So there are modern archival systems that can protect you from, there's modern archival systems that can protect you from that kind of loss at a fraction of the price. And I'm talking a fraction, we're talking, like 1%, like Amazon Glacier. And although you could theoretically, delete an account or something like that, if you have multiple accounts where the keys can never come in contact with each other, there's ways of distributing, there's ways of achieving this effect far, far cheaper and actually much more reliably. Checksums are one of the most curious things I find. The idea of a checksum is you run an algorithm on a file and it generates a digital fingerprint, and that if anything happens to the file, the fingerprint changes. The concern typically given is what's called bit rot. The idea is that magnetic signals degrade, you can have a bit flip. But the thing is that reflects misunderstanding about how modern file systems work. The whole modern file systems have error correction built into them. As a matter of fact, everything in your computer and everything in the networks, everything has an error rate, and they have all kinds of error correction built into it. Otherwise, when you transmitted things, whether wirelessly or over wires, and when they're going through, otherwise all kinds of things would go wrong. The whole premise of checksums I find kind of curious, because it presumes that corruption could only occur in the object you're interested in, the object that you're preserving, not in the operating system, not in the hardware, not in any software component, not in your video driver or on the network or anything like that. And all of these things would create far bigger issues. I promise you that it's actually looking at the wrong thing. You say, well, how about intentional modification? Well, unless you keep the checksums separate from the objects themselves with different access controls, anyone who modifies it can also modify the checksum itself. And then you have the question of, let's suppose the checksum did not match. How would you know? And then how would you recover a good copy? And unless you have good procedures for that, and hardly anyone does, it wouldn't do you any good. Also, checksums, if you try to migrate the file, that would change the checksum. There's internal metadata within the file. If you change anything in there, that's not changing the file, but it will change the checksum, change the name, anything. There are a few things that are that add so little value and add so little value in proportion to the amount of energy that they receive. So yeah, don't worry about them. But you do need to worry about the problems that locks and checksums are designed to accommodate. You absolutely, to preserve things properly, it needs to be geographically distributed, and it needs to be stored in a way that it's protected from intentional and intentional or accidental modification. But there's ways to do it. I just don't use like regular scripts and locks. To kind of like circle back to what we were talking about at the beginning, be realistic. The key is to say, well, what do I need to do? And what do I have to work with? And start from there. The library might not be the best entity to engage in preservation activities. Many things require specialized knowledge to do effectively, and many communities already have their own domains. There's also commercial entities that might be better set up. When you embark on preservation activities, part of your analysis needs to be a determination, if the library is going to do it, is that the library is the best entity to do it. Because if the library is the best entity to do it, then the library should be doing it. If somebody else is the best entity, they should be doing it. And although I've talked about how when you migrate information that it can be lossy, ironically, sometimes that's the best way to preserve views. Things that are simple are typically more flexible. But at the same time, you have to be careful that you don't normalize out like the most important thing. For example, if you're trying to preserve image data sets that contain multidimensional images, and the dimensions in the images are actually important, you can't flatten that into TIFFs, even though everyone says, oh, TIFF is a great archival format. Because if you do that, you make them useless. It all depends on the case at hand. But if simplicity, if simple will still protect your core use case, then you're fine. One thing that you should always do is, when thinking about how successful your preservation is, think about how well it's protecting use. Not just now, but into the future. You have stuff coming in to your system, you're managing it, it's being used, hopefully. It's going to need, nothing lasts forever, so someday you're going to have to migrate that entire operation to some other system. If you can do that, you're great. But at the same time that you want to be able to do that, don't think in terms of success in terms of your system, just having your system looking like it's running smoothly. That's sort of like system administrators who talk about uptime. It's like, oh, we're running 99.99% of the time. That's not the same as saying that our computers, that 99.99% of the time, the people who use our servers were able to do what they needed to do. Another thing is to understand digital objects as their own things, and not just think of them as like physical objects. When digital preservation started, and actually when we first started creating digital objects, they mimic physical objects. Like, for example, early catalog records, it's like the same information that's on a paper catalog card, or like even serials check-in cards. In an ILS, they'd call them check-in cards because they used cards. Over time, this has been changing, and so if you think of the bit stream as like it's kind of like the Dead Sea Scrolls, where it's an actual artifact. These things don't actually exist. It's just signals that get copied around, and so you're not actually saving anything if you're not actually. Don't get fixated on a particular sequence of numbers. Think about the effect. For example, with theses and dissertations, ultimately what they are is a text narrative. Yes, they can have all kinds of things attached to them, but ultimately what it is it's narrative, and that's what you're trying to preserve. And with certain types of images, you're preserving maybe always, you're preserving, just the image part itself. Always think about what is really important here. What is the effect I need? Also, don't be afraid to look outside the library for solutions. Libraries don't have tons of resources, but there's a bunch of companies and other entities that do, and that engage in, that produce things that are actually incredibly useful for preservation. So just because it doesn't say library repository on it does not mean it's not your best tool. There's some amazing stuff out there. When you get right down to it, success depends on knowing only three things. What do you want to preserve? And why? What's so important about this stuff? And why is it so important? And that will tell you everything you need to know in terms of how to store it. Well, it won't tell you everything you need to know. It will inform your process so that you'll know what you need to do to be successful. And that is all I have.